this problem starts off with a neutral can and a negatively charged balloon. This can is neutral, as you can see, has 4 pluses and 4 minuses. The charge is counterbalanced, has 0 charge. When the balloon is brought close to the can but does not touch, it induces the negative electrons to run. So I'm going to erase these electrons. These are the negatives are the electrons. And remember, the positives cannot move. The protons are too big to move, but the negatives can. So the negatives do not want to be close at all to another negative, and that balloon has made them want to run to the other side. They're going to be along this side, spread out equally as far away as they can get from this negative charge. At this point, the can is polarized. This part is partially negative. If the balloon were to be moved, it would go backwards. So if the negative balloon was removed, it would go back to there. If the balloon comes back, it goes back to here. So if the balloon is removed, it will go back to neutral. And if the negative balloon is brought back, it's going to induce the negative charge and make the can polar. So this is reversible at this point. Now the next step is where it will get interesting. At this point we have a polar can. It can be reversed. The next step, the hand comes in and touches the can. This is going to act like a ground. So when the hand touches the can, it forms a ground. This is kind of the international sign for ground. And remember, a human can be a ground because it's much bigger than a can, but the human's also touching the ground, so it will go through the human to the ground. But with the can, it's probably just going into the human and the human's being like the ground. So at this point, this right here is kind of like a release valve for these negative charges. They want to get away. If they could run farther, they would, and the ground allows them to get away. And so they're going to run basically into the ground. And they will end up down here. And remember, in the ground there's a ton of charge, plus and minus, so the ground can give or take electrons. Because it's so large, it's really of no consequence to the ground. It doesn't really feel it. So we're now looking at the fourth step, where the hand moves away. And remember, this ground wire is the hand. And so at this point, you get this thing breaking. It disconnects quickly. So you basically do have no more ground. But look, the charges were left in the ground. The can no longer has the minus charges. So at this point, the can is permanently positive. The negative balloon could be moved away, and it would not affect. The can is now positive charge no matter what. Let's go through and label it as we went through. Here the can was neutral. The balloon, negative. The can is polar, but it's neutral. Here, the negative charges run out. The can is now positive, and the balloon is still negative. And at this point, the can is permanently positive, and the balloon is negative. Of the 4 ways to charge an item, friction, conduction, induction, or grounding, we actually saw 2 at play here. We saw induction here because this negative ball induced the electrons to run without touching the can. And we saw the ground being used here, giving the electrons a release valve to run to the ground. But the primary force was this negative balloon. It's the one that really drove this charging. So we would say this is induction.